we're going to solve this practice problems good in class, going for the power for the 4 ohm resistor. So the first thing I'm going to do, I'm going to walk through and pulling out each light bulb, seeing how they're going to affect the other ones. So if I pull out the 5, that's going to kill out everything. Not going to touch that. That affects everything. That's too big of an effect. I'm looking for small effects, if any at all. If I pull out the 2, everything else stays on. If I pull out the 1, that knocks out the 3. The 3 goes out. I'm like, okay, it's good to know. If I pull out the 3, the 1 goes out because it can't go through. So these two affect each other. If I pull out the 4, everything else stays on, nothing else is affected. So 1 and 3 affect each other and only each other. So based off of that, I'm going to simplify those in series. So those go to here. I had several questions on where do I draw this. So they're in series, so I just add them up. It gives me 4. So several questions on where do I draw this. Can I draw it here, here? It does not matter. That's a great question. It does not matter. Now, at this point, where the rough. So here we've got, if I pull out the 5, that affects everything. If I pull out the 2, nothing else is affected. If I pull out the 4, nothing else is affected. If I pull out this 4, nothing else is affected. The current can still go through all that. So the fastest way to do it would be to say that 2, 4, and 4 are all in parallel and lump them together. However, several of you, which is not illegal, did it in steps of like 4 and 4 in parallel and then combining these two in parallel. I'll go through the fast way first, and then I'll do it the way that I saw a lot of people doing it. So I'm going to put these together in parallel. So I've got 1 over r is equal to 1 over 2 plus 1 over 4 plus 1 over 4. That gives me 4 over 4 because this becomes 2/4. So that's 1 over 1, and so I find that to be equal to 1. Okay, so I'm going to redraw, and my circuit looks like this. So 5, 1, and then lastly, redrawing that. These are in series. So you have 6 ohms. You have 120 volts. So at this point, we are now going to use Ohm's law and find all 3 variables of the resistor that we care about at every stage. That is an important, that's our strategy, okay? We need voltage, current, and resistance at every level of the resistor I care about. This level, I've only got 1 resistor, 6 ohms. So I've got 6 ohms, I've got 120 volt gain here, so I have 120 volt drop. So I have 120 volt drop here. So voltage is equal to current times resistance. I've got 120 volts is equal to current unknown, 6 ohms. So current is equal to 20 amps. Okay, so 20 amps going through here, through this resistor. This resistor came from the 5 and the 1 wired in parallel or series. Series, what's the same in series? Current. Current's the same. So I have 20 amps coming from here and through here. I got that from this that I calculated there. So that's 20 amps going through there. Jumping up to this level. Which resistor do I care about? 5 or the 1? Well, the 4 is buried. Is it buried in the 1 or the 5? Buried in the 1. So this is the resistor that I care about. So I'm going to calculate all three things for that resistor. I know the current of 20 amps. I know the resistance of 1 ohm. So the only thing I'm missing is voltage. That's my voltage drop or potential drop. So I have 20 volt drop across that. Okay. Now, this 1 ohm resistor came from the 4, 2, or the 4, 4, and 2 in parallel. So what's the same in parallel? Voltage. So this guy here, 20 volts here. So I have 20 volts across here, 20 volts across here, and 20 volts across here. This is the one I care about. So I've got voltage is equal to current times resistance. I've got 20 volts is equal to current times 4 ohms. So current through here is 5 amps. And lastly, I'm looking for the power of this guy. So power is equal to current times volts. So I've calculated the current of 5 amps. And the voltage is 20 volts. Power is equal to 100 watts. And that's the answer. Okay. Now, several of you did an intermediate step, which is fine. You did this. You did you did 4 and 4 in parallel first, and then what you did was you jumped up here, or jump up here. So you had 5 ohms, 2 ohms, and you did 1 over 4 plus 1 over 4 gives you 2 over 4. So you get 2 ohms here. Okay. And then you're going to combine those. You're going to combine those in parallel, and you get R is equal to 1 over 2 plus 1 over 2 is equal to 2 over 2, and that gives you 1. So we're back here. Now, here's where this gets a little sticky. Okay, it's fine as long as you keep your head about what you're doing here. So at this point, we found you boil it all the way back down. You find you have volts of 20 volts across here. Now, this came from the combination of the 2 and the 2 from parallel. So you're like, parallel voltage is the same. So I'm going to pull this 20 volts from here. So I know there's 20 volts here and 20 volts here. And I'm going to find, see, my 4 is buried in this one. So I'm going to find all three pieces of information about this guy. So I've got 20 volts is equal to current times 2 ohms. So my current through this thing is 10 amps. Okay, so I got 10 amps going through this 2 right there. Now, when I look at this 2, this came from these 2 4s wired in parallel. They're parallel, so what's the same in parallel? Is voltage. So the temptation is to go, oh, I calculated amps, I'm going to use that over here. But this is from parallel. So the volts is the same, not the current. So we need to use still 20 volts for here and here, not current. So that's the only thing that got a little sticky. Okay, you can see that we use 20 volts from right there rather than 10 amps. Okay, so just a heads up on that one. Okay. And then for the second problem, this one is not so nice number wise. It gets ugly real fast. So this one, I wanted you to get exposed to one of these things. So if we pull out the 7, nothing goes out. If we pull out the 9, nothing goes out. If we pull out the 6, nothing goes out. If we pull out the 8, nothing goes out. So the temptation is to say, ho ho, they're all in parallel with each other. And this is not a purely parallel circuit, because if the 7 and the 9 went out, that would kill the entire circuit. If the 6 and the 8 went out, that would kill the entire circuit. So what we've got are we have two parallel circuits that are wired in series with each other. If you see that, you've got the 7 and the 9, and also the 6 and the 8 that are wired in parallel with respect to each other. So we're going to find the total resistance of those two. So 1 over 7 plus 1 over 9 gives us something nasty. I guess you can do, if you want to do, you get 16/63, and so you got 63 over 16. Personally, I kind of like just getting some decimals on that one. I know you're rounding, and your math teachers prefer not, but plus 9. So I find that to be 3.34. Sorry, 3.94 ohms for this guy, and then this one is 1/6 plus 1/8, so 3, 4, nope, 3, yep, 4. So you get 7/24. So R is equal to 24/7, which when you do that decimal wise, you get wait for it, oh, you gotta get it. 24 divided by 7, whatever that is, 3.43 ohms. Okay, so I'm going to redraw that. So we've got 3.94 ohms, and we've got 3.43 ohms. Now, if you pull out the 3.94, that kills everything. You pull out the 3.43, that kills everything. So these two are wired in series with each other. So combine those together. And our total resistance is equal to 3.94 plus 3.43. And we find that to be equal to 7.37. redraw. A lot of people are failing to do this last final redraw. Just recommending, it's a good idea. Okay, so you know this is 12 volts, so you have a 12 volt gain. Right here you need a 12 volt drop. So there's 12 volts across here. You can find your missing variable missing measurement current. So your current is equal to 1.63 amps. So this came from the combination of these two wired in series. So what's the same in series? Current. So you take the current measurement from here up to this one and this one, 1.63 amps. Okay. The resistor I care about is this one because this is where the 8 is buried. So I'm going to calculate the current. No, I have the current. I'm going to calculate the voltage. So I have 1.63 amps times 3.43 ohms. Volts is equal to times 5.58 volts. And then finally, this resistor came from 6 and 8 wired in parallel. So volts is the same. So we got 5.58 volts across this and 5.58 volts across that. And I want okay. So I've got 5.58 volts here. Current, I don't know yet. 8 ohms. Current is equal to 8 equals real close to 0.7 amps. And then power finally is equal to current times voltage, current 0.7 amps times volts of 5.58, not 12. That's the total voltage. I just want the voltage across that one resistor. So times 3.9. And that's our answer. Okay. Hopefully that cleared up some confusion. There you go.